So this is part of the mobile track, and we're talking about device fragmentation. So as you may have guessed, a big part of this talk is going to be about Android. But a few words about myself. My name is Iordanis Giannakakis, or a bit shorter, Jordan. I worked for Shazam for the last 3 years. I've been the Android team lead there for the last year and a half. And this is my Twitter handle in case you want to leave any comments and discuss with me about any of the issues. I'll be really happy to talk with you. So some questions about how Shazam works. As everybody knows, it's a very popular mobile app you can get from your Play Store or the App Store. You press the button, and if there's any audio around, we will try to recognize what it is. The backend is the magical part. It's powered by really powerful hardware. By the way, can anyone hear me? Should I? But you know, some people think of it like that. So, a couple of things we're going to talk about today. We're going to start with definitions about what exactly is fragmentation, what do we mean by clean code in this context. And then we're going to start talking about particular problems when it comes to fragmentation and its solution for its problem. So we're going to have a look at how people use the other platform to address some of these issues so we can make their app look nice both on phones and tablets. And use techniques like dependency injection and the MVP pattern and how they can make their test better. And at the end, we're going to leave about 10 minutes for a Q&A session. So you might have seen this diagram. It was pretty popular about 9 months ago. It shows the distribution of devices, of Android devices actually, about 9 months ago. And this is how I like to visualize what kind of things the problem, so device fragmentation. By the way, the link to this site is going to be provided at the end, so there's no reason why you can take it later. In a few words, fragmentation is a concern that if you write an app and you want it to run on all devices, sometimes you may not know how it's going to end up looking or behaving. So what are some parameters that cause this problem? First of all, this is for Android. It's 1 month old, so nothing will have changed since then. It shows that, first of all, we have something like 6% installation on Jelly Bean. That's, by the way, is for Play Store. It's not just particular to Shazam, it's for every app out there. And it shows that the most recent version, KitKat, is only used twice as much as a version that was out 4 years ago, Pro year. So that kind of highlights the problem pretty well, I think. On the other hand, you have Gingerbread, which also was late 2010, and is still used by 20%. One thing to note is that this is installation basis. It's not necessarily your active users. And we have seen from our own stats that a lot of time newer devices are being used and older devices tend to get used less. So that's something you might want to consider when you're targeting your applications. Another quite popular problem for Android is, of course, Android devices come in all shapes and sizes. We started with really small phones, 3 or 4 inches. Now we are up to 5-inch phones, maybe sometimes 6. In the meantime, we've had like 10-inch tablets, 7-inch tablets, and so on. These screens might have different resolutions, so the pixel density on each is different. So we may want to provide different assets and different icons for each version. So how do we do that nicely? Interesting enough, some screens are naturally oriented in portrait or landscape mode. So whenever product manager says, okay, just log it to portrait, that simply will not work. So you have to handle all cases. Apart from just Android though, most of the devices come with some services that come on top of it. On the left we can see the Google Play services, which is pretty much all phones have. And if you use Google Maps or Gmail, you will have these on your phone. If your phone is not enabled with Google Play services though, you may have a Kindle device, which actually is not Android. It's called Fire OS, but it's actually a fork from Android. And it has the Amazon services on top. So we have SMS, which is the notification system for cloud messaging, and different maps. And recently in the game we have Nokia X devices, which are targeted toward developing countries or emerging markets, let's say. And of course they have the Nokia Here maps, different push messaging of their own services. When we talk about different capabilities, as you may have read recently, we have Android Wear, which is targeted toward watches, and of course for the last year and a half or so we've had glasses. I'm not saying that every app has to run everywhere, but you have to consider that some parts of it may have to. So people tend to think of fragmentation as a real problem, but the question to think before you start writing your app is, does it really matter? There are techniques that are out there that we can use to address the problem, and the fact that we have all these different devices is exactly what makes Android a powerful platform, because customers, consumers have the option to pick the devices that they want. Most of the updates now will get pushed over the air, for example, for devices that have Google Play services enabled. And so recently we started seeing some OS features like keyboard or the actual main screen of the phone as applications that you download from the Play Store, and those get updated regularly, but they are not tied to a particular OS version. And on top of all these features, we also have official compatibility libraries, which we will see in a second, that are actually backporting features from later versions of the OS to early ones. So let's start with bad code and some definitions there. I'm sure we have all been there. But in the context of this talk, what do we mean about bad code? So we talked about all those different dimensions of device fragmentation. So we have screen sizes, we have OS versions. All these are, if we think all of these as parameters to if statements, then we can imagine that our code will be very heavily branched. Our if statements will become bigger and bigger, and the more dimensions we have the problem, the bigger the problem space becomes. So that will make a very small app unmaintainable long term. When we're following such an approach, we can see that instead of creating modules that have single responsibilities, we will be copying and pasting code everywhere. So that will increase duplication. And also, of course, how do you test the code base like that? It's going to be pretty impossible. So that's the productivity level we want to reach. So how do we address the problem? First of all, we want to make our code easy to understand. We want to optimize for reading and changing code. We spend much more time maintaining our code bases than actually writing them. So we want our objects to be simple. We want them to have single responsibilities that we can test easily, and of course we want to reuse them as much as possible. This is talk about mobile, so we have to consider some other dimension to the problem. We may not care about code quality because we're in a mobile world. A lot of us may have been contractors that are working on short-term projects, working by ourselves or a couple of people, so we don't have to optimize for reading and changing because we know where our code is, kind of. And if we start doing A/B testing, we're gonna throw away a lot of features. We're just gonna try things that we then throw away because not all of it might be successful. The problem becomes when suddenly your project has become more and more successful. The code base eventually will get bigger, and suddenly you will start having to recruit more people who will then, the learning curve which will then be terrible. And of course, if you have writing no tests in the meantime, it means that your code is legacy. You don't understand what it does, and there's no documentation for it. Some sirens out there. Okay. So right now we are targeting more and more devices. Our user base is as big as it has ever been. But in the meantime, you can see that by some metrics like code coverage, duplication, and violations, critical code violations, that our code base has been becoming better. So how have we done that? First of all, I'd like to start having a look at how we have used the platform itself to make the most of it. So Android comes with this really powerful resource framework, which is used to externalize anything that's not code. So anything that's under the res folder will be things like strings. It might be things like arbitrary values like booleans or colors. And most importantly, layouts. So when the system inflates, it's things that the system inflates and it creates views. We will have a look at this in a second. So the reason why it's very powerful is because the Android system at runtime, based on your current configuration, will decide what resource to use the best way. So these parameters can be anything like locale. So if you are based in Italy, your locale is set to Italian compared to Germany, you will get different assets. Exactly the same thing happens with all the screen variations that we saw earlier, like screen sizes, densities, orientation, and ratio. But importantly, the same applies to platform version. So a simple example, if you have your phone turned to portrait mode, the system will decide that it has to show you the layout for portrait mode. As soon as you turn it to landscape, the system will say, okay, the configuration has changed, so it will destroy your screen and will create a new one with the new configuration. And when we are want to target different devices, we may want to do something like this. So we may want to provide different layouts. So on a phone, we may have something that will look like a list, and on a tablet instead, we might have a bit more complicated layout. If we want to show exactly the same information on the same screens. We want to show different information. So taking Shazam as an example, when we have our result, our tag result, we will show a screen like the one on the right. That's for phones. And for tablets, we keep the screen that we had before, but we start sliding things on the right. So we don't show exactly the same information. So let's have a look at how we do that. So I'm going to start with the first example. So imagine we had a phone and we want to show this visual information. So it's just 3 lines somewhere that have some information. You may have noticed that, as we said earlier, this is a resource of type layout, but some magic happens as soon as we switch our layout to show how it would be like in a tablet. So we can see that it actually has changed layout completely. And we have started laying out things differently. So how do we do that? Anyone who's done a little bit of Android will have seen these weird names here. So we have different, for the same resources, we may have different directories. So we will have things like this SW720, which is not very readable, but it means that this will apply only to devices that have the shortest width of 720 device-independent pixels. So that's going to be something like 10-inch tablets. All this can vary, so it's not you don't have to always use this variable. This can change to 720. So you can easily see that we in our UI editor we can just easily switch between device types, and it will actually pick up what it should be showing. So that's pretty handy. If you want to do something a little bit more complicated, how many of you guys have done any Android at all? Okay. I'm not going to insist very much on this, but effectively the way you can do something like switching information on and off is by doing pretty much the same thing, but instead we now have to consider a Boolean value that we set in the values. So similarly to the layouts, we may have, as I said, like random values. You may have seen here that we say that the generic case, so this will apply to anything that's smaller than 720, will not be a large tablet. but whenever we had a minimum width of 720, we want to consider this as a large tablet, right? So as soon as the application bootstraps, this application on create method is the first thing that gets called when your application starts. So at bootstrap time, we do this check, we decide whether something is a large tablet, and then we decide to switch on and off a particular screen. By the way, all these components in Android have to be declared using the XML structure of the Android manifest. So we have switched on by default everything at the beginning of the compilation time, let's say. And then at runtime, the system says, okay, I have to switch, if I'm on a tablet, I'm going to switch off the phone case, which is these two things there. Cool, that's maybe not a very simple example for someone present on Android, but we do this all the time. So something we've gained by this is that we haven't had to write any code for the first example. So everything is handled by the system. We didn't have to write anything, so it's very easy to maintain. And it's also separating presentation to the logic. We are not going to pollute any of our application logic apart from the bootstrap method we just saw. And that has given us the flexibility that we require to show things on a tablet or on a phone. So the second thing we're going to have a look at is how we can make, how can write features that are cross-version compatible when the Android platform itself doesn't give you that. So we're going to have a look at compatibility libraries and basically see how these magic compatibility libraries work. And to make it more interesting, we're going to use dependency injection or our own dependency injection to help the overall design. So as an example, as a use case in this case, I'm going to use the shared preferences class. Shared preferences is used to store any preferences that the user might have. It's a convenience class that gives you that as a utility class. That has a subclass called editor, and that's helping you do any of the transactional stuff. So you get hold of an editor, you create some values, put some values, and then you call commit if you're on an older device. And if you're on a newer device, so Gingerbread and beyond, you call apply. The difference between those two is that commit will actually write to this asynchronously. So as soon as you hit commit, if you call this from the UI thread, it might have something like 200 or 300 milliseconds delay. So your UI will be laggy, and we don't want that. That's why the apply method was introduced. It writes things in memory first, and then asynchronously, whenever Android decides, it tries to do this. So if anyone has done any Android development, they might have come across the so-called compatibility libraries. Some of them, well, the main task we do is to backport OS features to earlier versions. So let's say you are on a Honeycomb version or ICS, you only use fragments, but on Gingerbread you don't. So how do they work? First of all, they check the version of the OS that you're currently running on, and gracefully degrade the experience based on that. They are deprecated by design. What that means is that if you start only supporting beyond a version level, you can get rid of these. They are designed to be removed at some point from your code base. And to make it easier, they use the same package structure. So as soon as you stop using the support library, then you can just change your imports and everything should work fine. These come in either by Google, they are official. For example, AppCompat brings the so-called action bar to versions earlier than Honeycomb, where it was first introduced. And also we get third-party compatibility libraries like Action Marshmallow, which did exactly the same thing before the AppCompat v7 was available, or 9 of Androids, which was bringing part of animation implementation framework introduced in Honeycomb to earlier versions. So, is anyone here familiar with the term dependency injection? Yeah. Okay. I think what it gives us, I'll start with the basics. So, dependency injection is used to break hard-coded dependencies, and what that means is that at runtime, we don't want to decide what we are running. We want to decide how it's running. We care about interfaces and not the particular implementation. The added benefit of that is that for test time, we can do the same thing. And when we have, for example, unit tests, we can use the same technique and swap our dependencies with mocks or fakes or whatever we prefer. So a very simple example would look like this. So we have a particular feature that has two implementations, the oral and the web implementation. If we didn't have dependency injection, the client would need to know both of these and at runtime decide, probably with an if statement, which we want to avoid, which one to use. And of course we don't like that. So what we can do is to make the client only know about the interface of that feature. And then we have a third, let's say, object, in this case the injector, that will decide what's available, what's the best, and pass it down to the client. So when we started with dependency injection, one of the main libraries that was available at the time was RoboJuice, and that was introducing quite a lot of runtime delay. So it was taking about seconds to start the app. And of course, that's not acceptable on a mobile app, especially when you just want to get Shazam out, press a button, and recognize the song that you're listening to. Also, I don't know if anyone here has used any like Java dependency injection frameworks, or Spring AutoWire, things like that. That is not necessarily the easier to follow, because sometimes you just don't know what dependency has been injected to your code. So we wanted to create something that's easy, that you can navigate in your IDE and figure out what's being used at any time. So no bytecode manipulation, probably just pure Java will do. And the other problem with Android is that when we run any Android code on the JVM, because we link against the Android jar, that's effectively a stub implementation. So if you did any of the methods of the Android jar, you will get this exception. So to address this issue, there is a library called Electric that will do some bytecode manipulation and pretend to be an Android system, although it isn't. And when you run tests like that, that's going to introduce quite a lot of latency. So a test that would normally take 10 milliseconds will probably now take a couple of seconds. So let's look at an example of how we like to do this. So we'll start with basic version, the A version of this. We have an activity. Right. So we start with something like this. The user case now is that if we start a screen and we want to save the fact in the preferences that we have visited this screen in the past. Probably that's to show some logging or something like that. To create the shared preferences, we have to use this method as a factory method from the system, from the Android system, that will give us an instance of a shared preferences object. And just by calling edit, we'll get hold of an editor object which will handle all the transactions. Of course, we need to know which versions we are running on runtime, so that's why we have to call something like this, which will actually give you the version of the device is. If it's a newer device, we call live, the fast method. If it's an older device, we call commit. The problem with this class as you can see, so this method, as we can see, is that first of all it has hard-coded dependency here, so this will be really difficult to swap in the context of a test, pretty nearly impossible. The same as this, it's very fiddly to start changing what the version will be like with RoboElectric. So what we did do is introduce our own compatibility editor. We know that the system calls the NOR constructor reflectively whenever it needs an activity. So the thing we added here was to actually add a single R constructor that the first constructor will delegate to. So the end result of what this method, what the previous method looks like is this. We know we magically got an editor somewhere, and we are calling this, we're saving this value. The magic happens here at this factory method, which is used to actually inject our dependency. So what happens there? We call exactly the same method to get hold from the system the shared preferences object, which we'll then use as a delegate in our compatibility editor. So what does that look like? First of all, we had to introduce our own interface for editor, which all it does is, first of all, the only thing it does is just change the namespace. That's all it does. As soon as that happens, we are just delegating to the system editor, but the only thing we change is to introduce this save method, which will then delegate to the write method, apply or commit depending on what version you are. So what we have achieved here is that we have externalized this if statement, and as soon as we stop supporting older systems, we can just delete our own editor, change the imports, and then everything will work fine just by using the system one. So that's the basics of a compatibility library. Another thing to note is that, as we saw earlier, we have to use a context, which on Android can be anything like an activity or a service. It gives some basic information, so you do need this context to create pretty much everything. And that's why in our injection mode method, sorry, we had to get hold of this application context. You can't create shared preferences without having a context from somewhere. So what we prefer to do is use the application itself as a context. And the way to do it is that on the create method, we just statically set an instance to the static variable. And this happens only once. You can use this then to use this as a context with any of your codes. So that's a very simple example that shows us how we can eliminate ifs from our application code. If you remember, we still have the if statement, but it's very deep into the compatibility library, which we will then be able to remove. So as long as this ugliness is hidden somewhere, we don't have to care about it on the rest of the application code. One thing I probably forgot to mention is that we can actually now start writing tests for this. So what would this look like? We said that we would normally use RoboElectric to try to mimic that magic method that gave us the shared preferences. But just by doing this change, a simple change, we can start treating main activity after the changes as a POJO. So we can just inject one of those mock editors. We have set the expectations and just treat it as a plain Java object. This is just plain JUnit 4. if you have noticed, we still use the roboelectric test runner, and that's the only reason why we do, is to be able to not get that exception when we're trying to use any activities. But we don't actually, roboelectric itself uses things like onCreate and onResume, but we don't have to worry about any of that. So it tries to mimic the activity lifecycle, but we can just not use that. So we've added tests, and now we have an editor that can be used anywhere else without having to resort to those weird if statements that cause more branching to our code. And we have actually gained more users because we can now start targeting versions that are earlier than the ones that could have this effect. So a very simple example for MVP, hopefully you find this interesting. So we briefly saw, okay, let's start with the use case again. We saw that some devices have Google Play services enabled, and those come with some services like maps, and also some social features like Google Plus signing by itself. So it comes with an SDK for talking to Google Plus. So this is coming from a real-world example. As soon as a user starts the app for the first time, we prompt to log in for Facebook, and in cases where the Google Play service is enabled, Google Plus as well. If they're not, we just hide that. We briefly saw some sample activities and their onCreate, onResume methods. This is a full diagram for an activities lifecycle, and as you can tell, it's pretty complex, right? And for most cases, we don't need to use all of these states. We just care about maybe one or two, as we saw earlier, the onCreate and the onResume. Most of the interesting stuff happens here, where the activity, so where the screen is actually on focus on the screen. So if you try to unit test an activity, it gets very, very difficult very, very soon. The problem is because Android will call all these callbacks, so onCreate, onResume, onStart, onResume. And at the same time, we're going to try to test presentation logic, and the combination of those two things is not very easy. The same thing as before. We get dependencies for Android on while we try to run tests on the JVM, and the only way to do this is roboelectric. So let's see how we will solve this problem using the MVP pattern. We have three pieces in play. One is a view that handles all the input and output to the actual system. So this is where Android will live. View is going to be Android. Then we have all the presentation logic in the presenter, which will then talk to our model. Our model can be any of the business logic. So model doesn't need to know anything about Android, so they are nicely separated. We can perfectly unit test the model and the presenter in isolation of the actual platform, so Android. So how does it look with Android? As we saw earlier, Android calls our screen in different phases, so it might say start or stop showing to the view. And then that's going to relay those calls to our presenter that needs to start doing different things with the model and then pushing the results back to the view. So the starting point for this is that we want to unit test easily our presentation logic. We don't want to run into those weird exceptions, so we don't want to have to touch Android at all. And because the view is right now very, very simple, we don't need to unit test it. There's not going to be any branching or any weird code in there. So let's have a look at how this would work in practice. There's going to be a couple of previous examples. So we'll start with the M, which is the model in our case. So model, as we said, this can be, let's start with how we would do it beforehand. So the way you actually check for the existence of place services is to try to use it. So you get hold of the package manager, you try to get hold of that package, the particular package, and if it throws an exception, it has to be gone, otherwise it's visible. So if it's gone, it means that the system didn't find it through an exception. That actually comes with the docs, and if anyone has played with the play services, that's how you have to do it. So yeah, it's not very pretty, is it? Using exceptions as control mechanism for your experiment. So, as you may have guessed, in our case, the model itself is the existence or not of Google Play services. It's not going to be a very complicated example. Normally in your model, you might have anything from like synchronizing things like cloud storage, or hitting your server for some reason, or looking at the local database. So anything that can be used to make a business decision. The actual implementation for this is the ugly part that we saw there. This is actually our model in this case. This is how we decide that it's available or it isn't. So the view can be very, very simple, a very, very simple interface that the presenter will talk to. Again, you can notice that there's no Android imports here. Everything is just pure Java at this point. It's two very simple methods, whether we should hide or show the Google Plus sign-in. The thing that actually implements this is our activity, so our screen. You can see that it implements the show or hide, very simple. There's no logic in here anymore, it's just hide or show parts of the screen. As you may have noticed, and if you compare it to the previous one, there's no try-catch methods in here, there's no logic, so there's no point in unit testing this anymore. So the way we delegate then to the presenter is as soon as the application on create gets called, so as soon as the system creates this script, we pass the model that we have got in a similar fashion with the dependency injection that we saw earlier, and pass this, which is the view. Importantly, the activity has now started, of course, implementing this, so that's why we passed this here. And this is where it all comes together. So the presenter now holds all the logic about the presentations. So you can see that it checks the model and it makes a decision about whether it should be showing or hiding a view. And I think if you look at this, even if you don't know anything about Android, you can understand what it does. It doesn't have to be used on an Android context anymore. It can be taken and used somewhere else. Obviously, probably you're not going to use it on an iOS app, but if that's what you want to do, sometimes you may be able to. Or some platform that uses Java. As you saw earlier, we want to unit test our presentation layer. That's about the only thing we want to test. So how do we do that? Again, we just use JMod like before, and just JUnit for. If you notice, there's no electric test runner here, so this is pure Java and it runs in JVM5. Couple of easy tests, so we just set the expectations to hide or show the Google Plus login, and we just pass the boolean about whether the play services are available or they are available. So if anyone has done like testing, this is like pretty simple stuff out of the box. Does anyone write tests here? Ladies? Okay.
Yeah. Do you mean that you don't test the model in this case, or you don't test the model at all?
No, we definitely test the model. The only thing we don't test is the implementation of how the view is implemented.
Yes, just
so we're not exactly, yeah, because we don't want to test activities, because we get to the Android world at that point, and it gets much more complicated. Model and presenter, definitely, yeah. In this case, I didn't test at all the model because it was really easy. Yeah, it was just an exception. Good question. So, for those of you who have written tests in the past, you may have noticed that they have to be pretty expressive for you to be able to maintain. Like if usually tests fall very out of date very quickly. So let's say you change, you make a very simple change on one side of your code base, and then some unit tests or integration tests somewhere else fail. If the code is not very easy to read, and if your tests don't explain what they're doing, it's very hard to reverse engineer them, trying to fix them as well. So we want our tests to be as expressive as possible, using probably something like natural language or something as close as that as possible. And for us, that has been one of the key requirements to how we do testing. We will also talk about flexibility. So we talked about different screens, different interfaces. So one of the things to discuss is how do we make sure that some of our tests run on phones or tablets, and how do we pick? One problem with test speed is that unless you are in the context of JUnit, so unless you're running unit tests, they're going to be really, really slow. So if you run, let's say, tests that actually deploy on devices, probably these are going to take something like 10 seconds each. So we will see how we address that as well. And last, we want our tests to have helpful diagnostics. So as we said earlier, if something breaks, first of all, we can actually see what the test is doing, but we should also see a message that actually says what we can do to fix the test. Testing can happen at various levels. Unit level, that are features provided by our classes, probably methods, but not strictly speaking just methods. Integration tests that are helping us test things like the boundaries of our system. That's the theory. So if you want to do any networking calls, and you want to test your HTTP client, let's say. Same thing with databases and everything that touches any system that's not ours. And then you have, on top of all those things, the higher level tests, which are called the system tests. That are actually, for the example of Android, probably they get deployed to actual devices. Then you have particular libraries that actually go and poke the device, press different buttons on the screen, and give you back the results. So we have some tools in our toolkit that will help us write that last level of tests, which is what we're going to be talking about today. Android comes with a pretty powerful instrumentation framework that different libraries like Robotum and Espresso use to actually, as I said, poke the UI and actually perform tests on the UI itself. I'm going to talk very briefly about the library that we wrote called Gwen. You'll see what it is. Before we look at it, let's have a look at what behavior tests are. Ideally, when we write a test, we describe part of its behavior. We describe what it does. We describe in a particular situation when the environment is set up in a particular way. When we do an action, we need to see a result. So the way to encode this is the given when then structure. We run all the arrangements on the given. We do some action on the when, and then we assert at the then phase. Pretty simple example. Let's say that our server has been configured to return a particular track, a particular result, as earlier. When the user taps the Shazam button, the big Shazam button, let's say, then the user will see the track result. I think this is very easy to read, right? And we can communicate this with, let's say, our product manager, our testers, and everyone will know exactly what we're talking about because it's natural language. So there are some tools out there, particularly for mobile, that are not native to Java or Android, that help you use things like Cucumber in the context of iOS applications and Android applications. But I find that the deployment and execution of these are quite weird, and every time we've tried running on these, we can see that they don't scale as we want to do. And on top of that, how many times have product managers actually seen any of the tests or test reports? Probably never happens, right? So we just agree, yes, this is what the system will do, okay, now let us go and do our thing. If we agree on that, I don't think there's going to be a particular problem. So, I mentioned Gwen earlier, so this is something that we wrote. Effectively what it is a very simple framework. Although framework is a big word for something like as simple as that. Effectively it's some syntactic sugar that will let you write tests in this way. So for example, we can see that a server here is involved in the arrangement. So given a server returns a track, the user is involved in an action, so it taps the Shazam button. Then the user can see the track result. So this feels exactly like the previous slide. And I think for developers it's very easy to understand what the test is doing. You may not want to ask your product manager to read this, but if you're talking to, let's say, QA people, they will probably understand what it does, right? I'm going to come back to the previous example. So if we are in a phone context, we will have a big screen with a big button that says touch to Shazam. Then when we recognize something, we show something like that. We show the results like that. And on the other hand, if we are on tablet, we show a little button up there. We don't really leave the screen ever when you're on tablet. So it will start doing animation up there. And as soon as it finds something, you will see the results sliding from the right-hand side. So it feels like a different test, right? Where if you wanted to write this in a traditional way, although it's the same feature, the same behavior, how would you go about writing this? So let's have a look at that. Let's see the naive approach. Solve here comes from Robotium, so this example uses Robotium to perform the test. If we're on a phone, first of all, just by looking at this method, because we can't really, we have to make some effort to understand what it does, right? It's not very clear. If you gave this to someone from like a product manager or a QA, they will tell you, I'm not sure what this does. We as programmers, we know that this is going to get hold of the big button, it's going to press it, and then it's going to have a look at the results and make sure that we can see the result full screen, so we know that we're on the phone. So this is going to be testing to someone phone. By the way, the server has somewhere here in our setup method has been arranged to return a particular result. So in the case of the tablet, we would have very similar test, but it still has to be slightly different. And it will be like this. You get hold of the smaller button, which lives on the top left side. We'll click on it. And instead of seeing the result full screen, we're going to try to look for a side panel coming from the right. So, as you can see, there's quite a bit of duplication here. We're trying to test the same behavior on phones and tablets, but our tests, funnily enough, look quite different. So what's a better way to do this? It's going to be doing exactly the same thing, just using solo, but we can now see that we have two new classes in play, server and the user. And that's what a test looks like. So it looks a bit magic, right? So this reads exactly the same as before, as we saw on the slide. So we have a given server takes a track. When a user shazams, then a user can see the results. So we know that the server is involved in an arrangement of our test, so that's why it implements the arranger interface. It's a marker interface, so no methods for you to implement there. And we just configure the same way our server to return a result. In the real world, what we use is a library which we call Hammock server, because it's using Hamcrest and the mock web server. So we actually spin up an HTTP, a trivial HTTP server that we then configure with paths and what responses it should be sending. No open source yet, but we are in the process of doing that. Going back to our test, we have the user, which is involved in an action and an assertion. So for that reason, it's going to implement actor and asserter. And now it starts having some domain values to it. We will start having things like actions here. So the user has to, by the way, these are, again, our marker interfaces. There's no methods that we impose, so we don't have to implement anything. But we now have a domain. The user knows how to shazam, and knows how to look for things in the results. So that's pretty powerful, I think. The way we actually implement an action, again, using the same trick as before, using dependency injection, we have static factory methods that, depending on whether you're on a large tablet or a phone, we get the right action. Again, what is this doing? The device class decider. It is using dependency injection to get hold of our resources. And as we saw in the very, very first example, it's going to talk to your resources and see whether it's declaring itself to be a large tablet or not. So if we decide it's a large tablet, we're going to do something that a large tablet should do. So hitting the tablet button. If it's not a large tablet, we're going to use the phone action instead. And in here, for both examples, you can see that we have chopped up what the first tests were doing, but we've actually hidden all the details about how these tests are implemented. How these actions work. Okay. Same thing for this. We're looking for the small button instead. Assertions work very, very similar in a very, very similar way. With the same trick here to understand whether we should be looking for a full screen result or a side panel on the right hand side. So what these assertions look like, again, we look for, we use Solo to introspect the view hierarchy. We make sure that there is no, we make sure that it's not a full screen result effectively. It comes from the side panel. I haven't actually implemented for the purpose of this demonstration the condition. This is coming from Solo, so from Robotium. And it has to be satisfied to determine whether the test will pass or not. But you can do that at your own time. Should be pretty good. So, starting to do this, now we have almost like a dictionary of things that the users can do. Because we have a sum action, and we have an assertion for actually seeing a result, a track. So this starts becoming very powerful. As soon as you start having enough of these, writing a test becomes trivial because you just keep adding methods to the user, and then it might take like 5 minutes to write a new behavior test.
So you're almost mapping your user stories into your user test.
That's exactly what we do.
Yeah.
That's exactly what we do.
So how much, presumably, you're going to have someone out of overheads to get it all set up, because you've got to create your test, user tests, actions, all the rest of it.
We're going to go to performance in a second, so it's going to be in the next slide. But we're very interested in performance as well, so you'll see. So anything that does tests on real devices, just any of the tools that we have investigated, try to use, runs all the tests on all the devices, so all these behavior tests verify on each device that they actually work, but we don't necessarily always need that. So the same thing happens for device drones, also very expensive to hire. And build tools like Gradle and Maven have exactly the same problems. But if you've used Gradle or Maven, yeah. So another example of a tool that does exactly the same thing is Spoon. Spoon is a pretty nifty tool. Actually, what it does is you use it as a test runner, and then it runs all the tests on a bunch of all connected devices or emulators. And then at the end, it spits out these beautiful reports. You can navigate, these are clickable, so you can navigate and see when things are broken, for example. And it's open source, and you can use it or change it as you prefer.
So sorry, is that run off of one test server with lots of devices plugged into it?
Exactly, yeah. We also use it on our dev machines. The big difference is that because it runs all tests on all devices, it's slower to run. So this is what we did. We created fork, which is only a companion for Spoon. And the reason we call it fork is not just because of Spoon, but because it actually partitions the tests. So let's say at Shazam we have something like 250 tests. And if you have 10 connected devices that all consist of one pool, it's going to run about 25 tests on each device, not all of them on all devices. So the reason why that happens is, of course, it gives us quite a lot of speed. If you have 20 devices, your testing time will be smaller. That's actually helping us with our current setup, helps us to run tests with this speed, so about one test in 3 seconds. And if you think about it, it's pretty comparable to roboelectric tests, which take about 1 or 2 seconds. So this offers much more coverage than a unit test, and it runs at about 3 times as long, so it's pretty powerful. Interesting enough, we also invited some configuration flags with which we can configure how these pools get auto-generated. So for example, if you see this slide, I don't know if you can read it, but here it says tablets and here it says phones. So for things that are larger than a given dimension, we can say create a pool there and create a pool for phones for everything else. So again, these are going to be clickable, and they're going to show you that you've run all the tests on 2 pools, not just not on every device. Similar to Spoon, we kind of rip this off. It gives you some diagnosis about if something failed. We get hold of screenshots at the time, logs. so we can easily figure out what is broken. I think this is the last one, and we're talking about flexibility. So we talked about how do we determine which tests run on which devices. So when you have, for example, a large tablet, you may not want to apply all tests. So that is these annotations and an annotation processor on the robotic test runner that can actually scan annotated methods and skip them when they have to. So this way we can do things like that. So we can skip large tablets if some tests only apply to phones, or we should skip when place services are not available because, for example, we want to test our maps or explore function. So that's also pretty powerful and it has helped us write tests and run them quite easily. So, just summarize. I'm starting having a look at what fragmentation is and what clean code, briefly, what we would like it to be. We want to eliminate lots of if statements. We want to unit test as much as possible, ideally outside of the Android context, just using JUnit without overlecting. So we started having a look at the powerful resource system that Android provides. We wrote our own compatibility library, and we saw how to apply the entity pattern to manage complexity on the presentation. And last, we saw some of the things we do that help us write automation tests a bit better. That's me. The link to all of the code snippets we just saw are there. I think you've already got the presentation slides from the organizers. And here are some of the links that are also on the presentation slides you must have read. So, any questions?
We're talking about Shazam and Android.
Yeah.
Shazam runs also on other devices.
Sure.
How you relate MVP stuff to other devices as well? So can you use the same pattern or use a different approach?
So some companies like Facebook, for example, they have one mobile team, so we don't separate between Android and iOS. Because pretty much everything we do depends on mobile. We have separate teams for Android and iOS and mobile. The question is, the answer is I can't really answer because we only work on the Android platform and we haven't really
So you're
done
separate
it.
team?
Yeah, it's completely separate. Did that help? Do you guys think that will use probably like, you know where to start?
I need to revise up on dependency injections.
Okay, that's cool.
So you said that fork available online.
So fork, when it's available, it's already open source. We use it, started as an Android project, but then we got rid of all the Android stuff, and now the server team also uses it. Funny enough, they started using the same technique for dependency injection, so they started writing their own dependency injection because they found lots of the Spring stuff was not giving them what they wanted. And they actually started using Gwen as well. Before, I think they were using JBehave, and like I said, I don't think it gave them anything more than having like pure Java tests. So now integration and acceptance tests, even other things are really like that. Yes, fork is something basically I wrote on the weekend. And because it was immensely useful, we started just jamming some pre-processing stuff that we had to have for the Android app, because we use things like test trails, which is where we keep our repository of test cases. So right now I'm in the process of removing all these dependencies so we can open source this, so it will be easier. Cool. Thank you very much.